This is the beginning of chapter 2. Before we do anything, I'm just going to show you guys how, and this section is all about dividing by fractions. So if I wrote the fraction, let's say 2/3 times, how about 1/4? Hopefully all of you can do that now. I'm not even going to worry about any whole numbers or improper fractions or mixed numbers. You just know that when you have two fractions and you have to multiply them together, you multiply straight across. 2 times 1 is 2, and 3 times 4 is 12, and that can be reduced to 1/6. Okay? This you should have learned last year. I'm pretty sure you guys did. Now, this is what we do when you divide by fractions. 2/3, okay, divided by 1/4. And it's called keep, change, flip.
Oh, I know you.
Stop, thank you. So you keep the first fraction the same. I'm just going to rewrite it as 2/3. You keep that the same. There's no change with that. So the 2/3, let me do it this way. I keep the 2/3 the same. And then I change the division to multiplication, which is kind of nice because you guys already know how to multiply. And so that's what I change. I change it from division to multiplication. And the last thing I do, you better be quiet. The last thing I do is that I flip the 1/4 to 4/1. I turn it upside down. And so you can see what I did there. And if you guys can remember that, you'll do well with this section. It's pretty easy. So now, if I divide 2/3 by 1/4, I've done the keep, change, flip. What's 2 times 4?
8.
What's 3 times 1?
3.
Okay, now we have an improper fraction. Now what do I do?
Make the mixed number.
3 goes into 8 how many times?
2.
What's left over?
2.
And there's your answer. So keep, change, flip.
I remember doing this last year.
You should, because I'm pretty sure she taught it to you guys. All right? Now, something else that you were probably taught last year, it's called reciprocals. That's kind of a mouthful word, and let's take a look at that really quick. Okay? This is what I'm talking about. Reciprocals. And it says two numbers whose product is 1 are reciprocals. So in algebra, it looks like this. And algebra is when you replace letters, or replace numbers with letters. So I could write A over B. Okay. Times B over A equals 1. And you're going, wait, with these letters, that doesn't make any sense. But I could do this. 2/3 times 3/2 equals, what's 2 times 3?
6.
What's 3 times 2?
6.
What does 6/6 equal?
1/2. 1 whole.
1. Any number over itself, and I talked about this briefly yesterday, equals 1. Doesn't matter what the number is. I could put 10.36 over 10.36. What's that equal? 1. This line right here, you guys, look at this. This line right here, that means divided by. So I could look at this as 10.36 divided by 10.36. If I wrote a division problem, 12 divided by 12, what's that equal? 1. If I wrote 17.78 divided by 17.78, what's the answer? 1. So keep in mind, this line right here, in any fraction, just simply means divided by. And so whenever you have a reciprocal, two fractions, doesn't matter what it is, it's going to equal 1. I could do 7 over 436 times 436 over 7. What's that equal? 1. And that is reciprocal. All right? So, you could. And that's a good point. I'm going to put up 10 points for noticing that. So let's go back to that. 7 over, I don't remember what I had, let's say 146 times 146 over 7. Mr. Lesueur rightly pointed out, couldn't you cross cancel? Yeah. 7 goes into 7 once, 146 goes into 146 once. That's 1 over 1 equals 1. Same thing. All right? So, let's go back to this. I wanted to show something to you guys. And all I did was I expanded this right here so you could see it a little bit better. Let's take a look at this. So they've got 8 divided by 16 is 1/2. And then they've got 8 times 1/16 is 1/2. It's the same thing. And then you can see 8 divided by 8, what's that equal? 1. And 8 times 1/8 equals 1. And you might say, well, wait a second, Mr. Glazer, that doesn't make any sense. Well, 8 divided by 8, I think you guys understand that, why that's 1. But let me prove to you that 8 times 1/8 equals 1. Let's do it. 8 times 1/8. I need to change that 8 into a fraction, right? 8 over 1 times 1 over 8. What do we have right here? What was I just talking about? What's that called? Nicely done, Mr. Williams. Reciprocals. I'm multiplying reciprocals. And that's always 1, and that's what they're telling us. That equals 1. Okay? So put up 10 points, Mr. Williams. So they've got a few more there for us. You can see 8 divided by 4. Well, yeah, you guys know that. That's 2. And 8 times 1/4. Or you could look at it this way, 1/4. What's that word that we use to replace multiplication that we talked about yesterday and the day before? No, the word, yeah, of. Nicely done. Put up 10 points. Of. 1/4 of 8. Well, what's a quarter of 8? What fits into 8 4 times evenly? 2. And look at that. It's 2. Okay? So let's go down a little bit further there. 8 divided by 2. Yeah, that's 4. 1. What's half of 8?
4.
4. It says it right there. So, what do you think 8 divided by 1/2 is? I'm not asking for what's half of 8. I'm asking what's 8 divided by 1/2. Another way to look at it is to ask yourself how many 1/2s fit into 8. Well, let me ask you this. Let's say this is 1 right here. And here's a half. How many halves are there? 1, 2. Because this equals 1, if that's 0, right? So how many halves are in 1? 2. How many halves are in 2?
4.
So here'd be 2 more. And I heard you guys say it. So now there's 4. How many halves are in 3? 6. How many halves are in 4? 8. And then I could ask you, how many halves are in 8? 16. Okay? There'd be 16 halves in 8. And 8 times 2 is 16. How many quarters are in 8? What's 8 times 4?
32.
How many eighths are in 8? Or what's 8 divided by 1/8?
64.
What's 8 times 8?
64.
Okay. Let me give you a little visual aid for 8 divided by 1/2. Let me show you what I'm talking about here. I'm just going to draw a line. Okay. And I'm going to say this is 0 and this is 8. I don't know if I'm going to do this right or not. I'll see how close I can get here. So if this is a half, this would be what? 1. This would be another, this would be 1 and 1/2. What would this be? 2. And then 3, 4, 5, 6, 7, 8. So I'll erase part of that because there's my 8 right there. All right. Now, with each one of these, of course, that would be what? 2 and 1/2. This would be 3 and 1/2, and so forth. Now, going back to this question right here, take a look at this. I'm asking, or they're asking, 8 divided by 1/2 right here. How many 1/2s are in 8?
16.
And we already decided it was 16. Well, I'll prove it to you. Let's count them. This is a half right here, right? So there's 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? Kind of cool how that works out. All right.
Multiply the number by 2 and it would show you how many halves are.
You could, but for those that can't understand how you got that, this is kind of a visual aid. All right. So let's see here. We've talked about reciprocals. We went over those tables there. Showed you how you divide fractions, keep, change, flip. So now I'm dropping down to the 2.2 exercises. Let's look at that really quick here. And I'll do some of these and I'll show you what I want you guys to do. In fact, I'll just highlight those right now. So let's see here. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Let's go down a little bit further. 26. Look at 28 and figure out what they did wrong. Let me write that down. What did they do wrong. Okay, and this will be worth a stick. Take a look at the problem and figure out what they did wrong. I want you to do 30. And we'll stop there. So let's look at a couple of these.
Wait, is 4 the first one?
Yeah, I think so. Let's look at number 16 for a moment. So that's 12 over what, 25 is that? Divided by 4. What's the problem here? Can you multiply or divide a fraction by a whole number? No, you need to change that whole number into a fraction. So what does it become? 12 over 25 divided by what?
Divided by 4.
4 over 1. That's right. Remember, just put a 1 underneath a whole number to make a fraction. So now we're going to do, remember what it's called? Keep, change,
Flip.
flip. So I'll rewrite this as, I'm going to keep it as 12 over 25. Change it to multiplication, and now flip it. 1 over 4. And I'll just put the equal sign. Well, what's 12 times 1 equal?
12.
What's 25 times 4?
100.
It's what?
100.
Well, oh, I thought you said 400. Yes, it is 100. Yeah, because there's what? 4 quarters in a dollar, so it's 100. Now, can we reduce that? Yeah, because I can look at that and I know right away both numbers, 12 and 100, can be divided by 2, so I can reduce it. How many times does 2 go into 12?
6.
How many times does 2 go into 50? I'm sorry, I gave it away, didn't I? Whoops. How many times does 2 go into 100? 50. Okay. And those two numbers can still be divided by 2. How many times does 2 go into 6? 3 times.
And then.
How many times does 2 go into 50?
25.
25. Can we reduce it any further?
No.
No. And you know why? Because 3 is prime. Once you have a prime number, whether it's the numerator or the denominator, if one of those is prime, you can't reduce it.
So is that the answer to 16?
So that's the answer to 16. Okay, Mr. Conyers?
When you're flipping it, do you just flip the right fraction
Yes,
and
that's
then change the division to multiplication?
that's it. So let me write, I'm going to show you one more. So let's say I had 2/3 divided by, let's say,
7/5.
okay, whoops, not 7/5. How about 5/7? Okay, and so it's keep. I'm going to write keep here, change here, and flip. Okay, so keep the 2/3 the same, change it from division to multiplication, and then finally you would flip just the last fraction, which is what Mr. Conyers was asking me. So I could rewrite this as simply 2/3, change it to multiplication, and flip it to 7/5. And then I would just solve it, just multiply straight across. Okay? So this is almost 20 minutes long. I'm going to stop the video here, and then I'll answer some more questions because I see some hands up. Stop